Have you ever dropped a rock into a pond? It sinks immediately, disappearing beneath the surface. Now what about an empty plastic bottle? It bobs right on top. It floats. Simple, right? But then there's a submarine. A massive ship made of thousands of tons of solid steel. How can it sink like a rock and then float like a bottle whenever it wants to? Think about playing in a swimming pool. If you hold a big breath of air in your lungs, you float very easily near the surface. But when you exhale all that air, your body feels heavier in the water and you start to sink. You are actively changing your own buoyancy. A submarine does the same thing, just on a much bigger scale. The hidden problem is the submarine's incredible weight. It is one of the heaviest machines humans have ever built. If you just placed all that steel in the ocean, it would plummet straight to the seabed. There's no question about it. Yet it also needs to operate like a regular ship, floating on the surface to travel long distances or enter a port. So the challenge for engineers was immense. How do you design one machine that can be both a boat and a stone and switch between them on command? The answer lies in a fundamental principle of physics. It's all about controlling an invisible force called buoyancy. Buoyancy is the upward push that water exerts on any object submerged in it. It's what makes things feel lighter in water. The key to floating or sinking is a concept called density, which is just how much stuff is packed into a certain amount of space. If an object is less dense than the water around it, the upward push of buoyancy is stronger than the object's weight, and it floats. If it's more dense, its weight overpowers the buoyant force, and it sinks. A submarine works by changing its own density. The brilliant engineering solution is hidden between the submarine's inner and outer hulls. Here lie huge, specialized containers called ballast tanks. When a submarine is cruising on the surface, these ballast tanks are filled mostly with air. The huge volume of air makes the submarine's average density much lower than that of the surrounding seawater, so it floats high, just like a ship. To begin a dive, the crew opens large valves at the top and bottom of these tanks. These openings are called vents and floods. The air is pushed out through the vents at the top, while seawater rushes in through the floods at the bottom, filling the tanks. As the tanks fill with tons and tons of heavy water, the submarine's overall density starts to increase dramatically. Once its density becomes greater than the seawater, the submarine loses its positive buoyancy and begins its slow, controlled descent into the deep. The dive is not an uncontrolled fall. The crew carefully monitors the amount of water in the tanks. By closing the valves at just the right moment, they can achieve a perfect state called neutral buoyancy. This is the magic part. Neutral buoyancy means the submarine's density is exactly equal to the density of the surrounding water. It no longer sinks, and it doesn't rise. It is perfectly suspended, able to glide silently through the ocean depths. But how does it get back up? It has to get rid of all that incredibly heavy water inside its tanks. It can't just open the valves, because the immense pressure of the deep ocean would just force more water in. Instead, the submarine uses powerful compressors to blast highly pressurized air stored in flasks directly into the ballast tanks. This blast of air is much stronger than the water pressure outside. It violently forces the water out of the floods, emptying the tanks. As the water is replaced by air, the submarine rapidly becomes less dense and starts to rise, finally breaking the surface. In essence, a submarine works like a giant mechanical set of lungs, inhaling water to become heavy and exhaling it to become light. It's a simple but brilliant solution to a very complex problem, mastering a basic law of physics to navigate two different worlds. It shows us that the greatest feats of engineering often come not from fighting the laws of nature, but from understanding them.